Hello, this is Dr. Hanaa Assil and this is paper 1CR of May 2023. So we're going to take a look at the questions and discuss the answers. The first question says, oxygen can be stored in tanks as a liquid or as a gas. Complete the diagram to show the arrangement of 6 more particles in a gas. So we're supposed to draw 6 particles in a gas, and that means they should be in no particular order, so they should be randomly arranged and far apart. So this is something like this. Give a reason why a tank can store much more oxygen as a liquid. Of course, if we have a certain volume, we can put more particles into that volume if it is a solid than a liquid than a gas, because if we're looking at a liquid, the particles are closer to each other than in a gas, so more particles can be placed in a certain volume. Identify a hazard when storing oxygen as a gas. Remember, we don't say oxygen is flammable. We say it can cause burning. It can cause other things to burn. So it may cause an explosion, but don't say it burns or it is flammable. Oxygen is not flammable. Flammable substances need oxygen in order to burn, but oxygen itself, we don't refer to it as flammable. So we say it could cause an explosion because it could cause something else to burn. Sulfur burns in oxygen to form sulfur dioxide. Give one observation that can be made when sulfur burns in oxygen. You should remember that when sulfur burns, it burns with a blue flame. So you should know, for example, if magnesium burns with a white flame, but sulfur burns with a blue flame. Some universal indicator is added to sulfur dioxide. Explain the final color of the universal indicator. Now you should know that sulfur dioxide is acidic, and that means if it is dissolved in water, it forms an acid. Now SO2, sulfur dioxide, if it is directly dissolved in water, the acid that is formed is actually sulfurous acid. But if this sulfurous acid is oxidized, or if the sulfur dioxide is oxidized to form sulfur trioxide, then dissolving that in water would cause sulfuric acid. So sulfur dioxide is acidic, and that means if we put universal indicator paper, it should turn red. This question is about mixtures and compounds. The box gives some techniques used to separate mixtures. The table lists some substances and mixtures. Complete the table using words from the box to show the best technique to obtain the named substance from each mixture. So if we're trying to get solid sodium chloride from aqueous sodium chloride, that means we have the solution and we want what? We want the solid. This is by crystallization. What if we have a solution but we want the water? If we want water, for example, from aqueous copper sulfate or from any solution, we use simple distillation. What if I'm trying to separate sand from sand and water? Of course, sand is something that does not dissolve in water, so we separate it by filtration. Then the question says, state how this box represents a mixture. So why do we say this is a mixture? Of course, this is because it is made up of different substances that are added together. So we have 2 different types of elements. One of them is monatomic and the other is diatomic. So we have different substances added together. Food colorings are mixtures of food dyes. A student uses paper chromatography to separate the food dyes contained in food coloring D. The student places spots of 3 food dyes, A, B, and C, and food coloring D on chromatography paper. The diagram shows the appearance of the paper after the experiment. Describe the composition of D. So if we look at D, what did they find is present in D? Of course, if spots go up the same height, then they are the same. So what do we have? We have the spot going up the same height as A, and we have a spot going up the same height as C, and that means that D contains A and C. It doesn't have B because it doesn't have a spot the same height as B. And at the same time, D has a third spot which is unknown. It's not similar to any of the others. So we say it contains A and C and a third unknown substance, but it does not contain B. A compound has this formula. Determine the number of different elements in this compound. Different elements. What do we have? We have calcium, hydrogen, carbon, and oxygen. So actually we have 4 different elements. But if the question says determine the number of atoms, what is the total number of atoms? So the first question says the number of different elements. Now we want the number of atoms. For this compound, I have 1 calcium, 2 hydrogens, 2 carbons, and 6 oxygens. Can you see that? Any number inside, so the 3 applies only to oxygen, but the number outside the bracket applies to everything inside the bracket, so the total number of atoms is 11. Question 3 says the diagram represents an atom of an element. What is the particle labeled W? Of course, W is the particle that revolves around the nucleus in energy level. So you know that in any atom we have a nucleus. That's the central part, and the central part contains protons and neutrons. And anything revolving around the nucleus, that is an electron. An atom of this element contains 13 neutrons. What is the mass number? First of all, you should know the meaning of mass number. Mass number is the total number of protons plus neutrons. So we're told we have 13 neutrons. But how many protons? Well, you should know that the number of the protons is the same as the number of electrons, since this is an atom. So that means if you count the electrons, they are 12. That means we also have 12 protons. We're told we have 13 neutrons. So the total, that's the mass number, which is 25. State why atoms have no overall charge. Well, you should know that an atom is neutral. This is because it has equal number of positive protons and negative electrons. So in an atom, the number of protons, which is positively charged, is equal to the number of electrons, which are negatively charged. So there is no overall charge for the atom. What is the charge on the ion usually formed from this element? So we were given this element. If it is going to form an ion, you should look at what? The number of electrons in outer shell. It has 2 electrons in outer shell, so obviously this is something in group 2. If it were to form an ion, it would lose these 2 electrons in the outer shell, and that means it would have a net charge of +2 or 2+. There are two isotopes of the element lithium. State why both isotopes react in the same way. Remember, we said isotopes of any element react in the same way because the isotopes have the same number of electrons. Remember, the reactions that an element does depends on the number of electrons and electron distribution. Isotopes, if we say what are isotopes, you should know isotopes are atoms having the same atomic number, so they have the same number of protons, same number of electrons, but different number of what? Different number of neutrons. A sample of lithium contains this percentage and this percentage of the other one. Calculate the relative atomic mass of this sample of lithium. Remember, if we are given the percentages of each isotope, how do we get the relative atomic mass? Well, the abundance of one times the mass number, so the mass number is the big one, not the small one, plus the percentage of the other one times the mass number over 100. The percentages should be a total of 100. So this comes out to be 6.924. Have we finished? Please notice the question says give your answer to 2 decimal places. So this has to be 6.92. That's how you, and please remember to round up correctly. So this in 2 decimal places is 6.92. Question 4 says, this question is about gases and we have a table and you are required to choose from that table the most abundant gas in air. Which of these is the most abundant gas in air? You should know that air has mostly nitrogen, about 78% nitrogen. A toxic gas that is a product of incomplete combustion of hydrocarbons. We said if hydrocarbons do incomplete combustion, they form which of these gases? They form carbon monoxide, which is toxic. An unreactive gas that exists as atoms. Now, unreactive gas that exists as atoms is something in group 0 or group 8, which are noble gases. So the question is, which of these is a noble gas? Helium. If you're not sure, please check. You have a copy of the periodic table at the beginning of your exam. A gas produced by the fractional distillation of crude oil. So fractional distillation of crude oil could give which of these? Of course, it gives hydrocarbons, so it could give methane. Okay, a teacher uses this apparatus to determine the percentage of oxygen in a sample of air. So we have copper powder in that tube. Record the total volume of air in the apparatus. Heat the copper powder. Use the syringes to pass air over the heated copper powder several times. Allow the remaining gas to cool and then record the final volume. And they notice that the copper powder turns black. Of course, if I were to heat this copper powder, you should know that what's happening is that the copper is reacting with oxygen in the air. So it is taking oxygen from the air. So why would the copper powder turn black? You should know that copper, when it reacts with oxygen, it forms copper oxide, and copper oxide is a black solid. So the copper turns black because it is oxidized to copper oxide, which is a black solid. Give a reason why the remaining gas is allowed to cool before we measure the volume. If we heat the apparatus, we have to leave it to cool before measuring the volume, and this is of course because gases expand when heated. So the volumes when it is hot is different from the volume when it is cold. If we measure the initial volume when it is cold, then we need at the end to leave it to cool before measuring the final volume. At the start of the experiment, the total volume of air in the apparatus was 138 centimeter cubed. At the end of the experiment, the volume of gas remaining is 108. Calculate percentage oxygen. So, of course, if I'm starting with 138 centimeter cubed of air, then the copper is going to react with the oxygen in the air, and we're told assume that all the oxygen has reacted, and that means the amount of oxygen is actually the difference between the initial volume and the final volume, and to get the percentage we put the difference over the initial times 100. So the 138 minus the 108, that's the volume of oxygen that was used over the initial volume times 100. This comes out here to 21.7%. Question 5 is about iron. One problem with iron is that it rusts. Name the two substances that iron reacts with when it rusts. You should know that iron originally is silvery in color or silvery gray in color, but then when it rusts, it becomes reddish brown. Now, why is it rusting? Remember, the iron reacts with what? With water and oxygen to form what we call rust. And if we are told what is the chemical name of rust, rust is actually hydrated iron 3 oxide. So name the two substances that the iron reacts with when it rusts: water and oxygen. What type of reaction occurs when iron rusts? Well, you should know, if I'm changing from iron to iron 3 oxide, that means I'm gaining oxygen, and that is oxidation. Iron can be prevented from rusting by painting or by coating with zinc. Explain how painting prevents iron from rusting. So if we paint iron gates or iron windows, why does this prevent the iron from rusting? Of course, we say that the paint on the iron is acting as a barrier. So the paint acts as a barrier to prevent the reaction of iron with oxygen and water vapor in the air, and that is why it doesn't rust when it is painted. Remember, if the layer of paint is removed, that part of the iron would rust. Name the process used to coat iron with zinc. If I have iron and we coat it with zinc, that is galvanizing. So you should know that what is meant by galvanizing. It is covering the iron with a layer of zinc by dipping or spraying. Now explain why a layer of zinc protects the iron from rusting even if the layer of zinc is scratched. So if we do galvanizing and a part of the zinc is scratched, still no rusting happens. Remember that when we have zinc, zinc is more reactive than iron, so it loses electrons and becomes oxidized instead of the iron, or in preference to the iron. So long as there is a piece of zinc touching the iron, it is the zinc that would react and not the iron until there is no more zinc. Iron is formed when aluminium reacts with iron 3 oxide. This is the equation. So we have aluminium plus iron 3 oxide to give aluminium oxide plus iron. Explain what this reaction shows about the relative reactivities of aluminium and iron. Remember, we have something called reactivity series, and we said a metal above in the reactivity series is more reactive, and that would displace any metal below it in the reactivity series. Now, when we look at this reaction, obviously the aluminium has displaced the iron. It has pushed the iron out of the oxide. So aluminium is more reactive than iron since it can displace it. The metal that can displace the other one is the more reactive. Explain which substance acts as an oxidizing agent. Okay, let's take a look. This was the equation. Now, what happened to the aluminium? The aluminium changed into aluminium oxide. That is oxidation. So we say aluminium has been oxidized. That means it is acting as a reducing agent. What about the iron 3 oxide? You can see that the iron 3 oxide has changed into iron. That means it has lost oxygen. That is reduction. Now, when it lost the oxygen, it gave the oxygen to the aluminium. So that is the oxidizing agent. So remember, which one is the oxidizing agent? It's the one that gets reduced. So the one that is reduced gives up its oxygen to the other element, so it is an oxidizing agent. So the iron 3 oxide is oxidizing agent because it lost oxygen, or it gave the oxygen to aluminium, causing the aluminium to be oxidized. A student uses this apparatus to investigate the rate of reaction when hydrogen peroxide solution decomposes. So we have the equation and we are told, give a reason why the gas that collects in the gas syringe is not pure oxygen. So we have in the conical flask, we have H2O2, hydrogen peroxide. And we said when it breaks up, it gives oxygen gas. So the oxygen gas should collect in the gas syringe. But the question says the gas syringe doesn't have pure oxygen. Why is that? Well, that's because all that apparatus originally had air, or air that has oxygen and other things. So the oxygen that is formed pushes the air into the syringe. So the air from the conical flask goes into the syringe in addition to the oxygen that is being formed by the reaction. The rate of reaction can be increased by adding a catalyst. Describe how a catalyst increases the rate. How a catalyst increases the rate. So please don't just say it speeds up the reaction without being changed. That's the definition of a catalyst. The question says, how does it increase the rate? You should know that it provides an alternative pathway with lower activation energy. So if I have a reaction, reactants go into products originally without the catalyst, the activation energy is the difference in energy from the reactants to the top, so that's a high activation energy without the catalyst. But when we add a catalyst, what does it do? It provides an alternative pathway. That means it causes the reaction to happen in a different way that has lower activation energy. These solids catalyze the decomposition of hydrogen peroxide. So we know that lead oxide and manganese oxide both act as catalysts. Describe a method that the student should use to find out which solid is the more effective catalyst. So I want to know which of these is better. Of course, the one that is more effective is the one that makes the reaction faster. So we're asking, which of these makes the reaction faster? Well, how do I know? So I can have this set up again, and we weigh a specific amount of the first solid or the first catalyst using a balance, then put that into the flask connected to a gas syringe and add a specific amount of the hydrogen peroxide, let's say 25 centimeter cube of hydrogen peroxide, using the dropping funnel. And what do we do next? Determine the volume of gas collected in a specific time. So let's say in 2 minutes. Then we repeat this. Repeat using the same what? Using the same mass of the solid. So we're going to use, if we started with 5 grams of the first solid, repeat using 5 grams of the other solid. the same volume of hydrogen peroxide, the same temperature. Now, how do I know which one is a better catalyst? The one that gives more gas in that same amount of time is the better catalyst. Please learn how to explain this. A student investigates the decomposition of a solution of hydrogen peroxide at different temperatures. The graph shows how the total volume of oxygen collected in the syringe changes with time when the solution is at a temperature of 20 degrees Celsius. Now, on the grid, draw the graph, the curve the students would obtain at a temperature of 40 degrees. So if this is the graph they got at 20. Now, when they repeat the reaction at 40, what should happen? First of all, you should know 40 degrees Celsius is a higher temperature, and that means a faster reaction. Faster reaction means the graph should go up steeper than this one. So we want to draw a steeper curve. That means going up above this curve. What about the final volume of oxygen? Well, if we're using the same amount of hydrogen peroxide, then the same volume of oxygen should be obtained at the end. So we don't go up more, we don't get more oxygen, because the amount of oxygen depends on the amount of hydrogen peroxide. So we're told that all other conditions are the same. All they did was increase the temperature, and that means the reaction is just faster, a steeper curve, but same final volume of oxygen. A teacher uses this apparatus to test the products of combustion of liquid hydrocarbons. So they're burning a hydrocarbon and then passing the gases that come out into a U-tube dipped in ice and a conical flask that has lime water. And the question says, explain the change in appearance that occurs in the lime water. So we have to say what happens to the lime water and why. Of course, if we're burning a hydrocarbon, you should know that one of the products is carbon dioxide gas. Now, if the carbon dioxide gas goes through that apparatus into the lime water turns milky due to the presence of carbon dioxide. And you should know why. You should know that lime water is actually calcium hydroxide. So, calcium hydroxide plus carbon dioxide passing through it, that becomes calcium carbonate, and you should know that calcium carbonate is not soluble, so it precipitates out, and this is what we see as cloudy or milky or a white precipitate forming in the lime water. The equation represents the complete combustion of an alkene. So we don't know what the alkene is, so it is CnH2n, we don't know exactly what. Burning in oxygen would give carbon dioxide plus water, and we are told that complete combustion of 0.01 mole of alkene produces 2.16 grams of water. And the first question is, determine the molecular formula of the alkene. What was the alkene? Well, if it produces 2.16 grams of water, then the first thing I should do is get the number of moles of water. And you should know number of moles is mass over molecular mass. So the mass we're given over the molecular mass of water, this gives 0.12 moles of water. Now, if we look at the equation, we are told that we're starting with 0.01 mole of the alkene. So that means when we start with 0.01 mole of the alkene, we got 0.12 mole of water. So from the equation I want, what would I get if I'm starting with 1 mole of CnH2n? So simple cross multiplication, if I'm starting with 1 mole of the alkene, I should end up with 12 moles of water. And that means in that equation, N is 12. So, what is the formula of the alkene? Now, hydrogen after the arrow is 2 times 12. So, hydrogen before the arrow should also be 2 times 12. That's 24. And we know that this is an alkene, so the number of carbons is half the number of hydrogens, and that means the formula is C12H24. Give a reason why the mass of pure water that actually collects in the U-tube is less than 2.16. So we said when the water vapor comes out, it should cool and condense in that U-tube because of the ice. But usually we don't get exactly the amount we're supposed to get. This is because some of the water vapor will continue to go through the apparatus and it is not condensed by the ice, so the water vapor is lost out of the apparatus. Give a physical test to show that the water that collects in the U-tube is pure. So we want a physical test for water, or test to show that the water is pure. How do we do that? Heat the liquid to boiling. It should boil at 100 degrees Celsius. This is the physical test for water, or test for pure water. The teacher burns 30 grams of heptane. This is the equation for the complete combustion of heptane. Calculate the mass of oxygen needed for complete combustion of the heptane. So we're given information about heptane. The first thing we need to do is get the number of moles. So number of moles of heptane is the mass we're given over the MR, which we're also given. So this gives number of moles of heptane. Then we go to the equation. What are we asked about? We're asked about oxygen. And from the equation, 1 mole of the heptane reacts with 11 moles of oxygen, and that means the number of moles of oxygen needed would be 11 times what we got. So that comes out to 3.3 moles. Now, what are we asked to calculate? It says calculate the mass of oxygen. How do we get mass of oxygen? Number of moles times MR, and this is oxygen O2. So even if we're not given the MR, you should know that this is 16 times 2, so that's 32. And that means the mass of oxygen needed to react with the heptane is 105.6 grams. Diamond, graphite, and fullerene are all forms of carbon. The diagram shows the structures. Explain why graphite conducts electricity. So why does graphite conduct electricity? You should know because it has free what? Delocalized electrons. Remember, graphite is the only non-metal that conducts electricity. Why does it conduct electricity? We said each carbon is bonded to only 3 carbons, so each carbon has 1 electron floating around, so we say it has delocalized electrons that are free to move. Explain why diamond is hard, but graphite is soft. You should know. Diamond is hard because it has what? It has rigid 3-dimensional tetrahedral structure. Why is graphite soft? Because the layers of carbon atoms can slide over each other. This is just 2 marks, so these are enough for the 2 marks. Sometimes this question has more marks, then you need to explain more in detail. Doctors use C60 fullerene to deliver medicines to certain parts of the body so that the medicine does not damage other parts of the body. So just why C60 fullerene is suitable to be used to deliver medicines? Well, one of the reasons could be because it's not reactive, so it is not toxic, it would not react with anything in our body. So that is one reason. Another reason could be it is small and it can take the medicine into it and go through the body so that it delivers the medicine to a specific part of the body. Question 9 says calcium nitrate has this formula. Give the formula of each ion in calcium nitrate. So I want to write the formula of calcium ion. When we write the formula of an ion, you write the symbol and the charges. And you should know that the number of charges is the same as the valency. The first ion in the compound is usually positive and the second one is negative. So calcium has a formula of Ca2+. The calcium ion is 2+. The nitrate ion, you should know that nitrate, the valency is 1, and that means it has 1 negative on it. Explain why calcium nitrate has high melting point. Well, you should know that calcium nitrate is what? It's ionic. So refer to structure and bonding, why any ionic compound has high melting point. So the question is, why is this ionic or any ionic compound, why does it have a high melting point? Remember, ionic compounds have high melting point due to strong electrostatic attraction forces between positive and negative ions, whereas to refer to structure and bonding, so positive and negative ions in the giant three-dimensional crystal lattice, which need a lot of energy to be broken. So this is why calcium nitrate or any ionic compound has high melting point due to strong electrostatic attraction forces between positive and negative ions or oppositely charged ions in the giant three-dimensional crystal lattice. Remember, ionic compounds, the structure is a crystal lattice which needs a lot of energy to be broken. Calcium nitrate decomposes when heated. Complete the chemical equation for decomposition of calcium nitrate. So we're already given the equation, so all we need to do is balance. Again, to balance, just count how many before the arrow and after the arrow and increase the one that is less. And we usually leave oxygen till the end. So how many calcium before the arrow? Well, so far we have 1. How many calcium after the arrow? 1. So far it's balanced. How many nitrogens before the arrow? Remember we said a number below applies only to the element immediately before it. So that 3 there applies only to oxygen. But the 2 outside the bracket applies to everything inside. So actually we have 2 nitrogens. So first we need to put 2 here so that we balance the nitrogens. Then we count how many oxygens before the arrow. Before the arrow we have 2 times 3. 2 times 3, so that's 6. How many oxygens after the arrow? 1 plus 2 times 2, which is 4, so that's 5, 6, 7. So we have 7 oxygens after the arrow, 6 oxygens before the arrow, so we increase the one that is less. That means I put 2, and then I start again. That means my calcium now is 2, so I need 2 here. Now how many nitrogens before the arrow? Before the arrow we have 2 times 2, which is 4, so I need 4 here before the nitrogen. Now how many oxygens before the arrow? 2 times 3, 6, times 2, 12. I have 12 oxygens before the arrow. After the arrow I have what? I have 2 plus 2 times 4, that's 8. 8 and 2, 10, and 2, 12. So now it is balanced. A student has 4 unlabeled beakers, each containing a colorless solution, which could be calcium bromide, calcium chloride, sodium sulfate. Describe a series of tests to identify each solution. Do not refer to safety precautions. So what do we have? We need to distinguish, is it sodium something or calcium something? That means we need to do tests for sodium ions and calcium ions, and you should know the test for that is flame test. So just say do flame test. Do not describe how to do a flame test unless if we're asked to do that. But here we just say do a flame test. Now you should know the colors that we obtained from a flame test. So you should realize that the calcium should give a brick red. So if I get brick red flame, that indicates calcium ions. But if I get a yellow flame, that indicates the sodium ions. Then I want to distinguish between what? Chloride and bromide. So in this case, I add aqueous nitric acid and silver nitrate. For the chloride, we get white precipitate. So if I get a white precipitate, that indicates chloride. If I get a cream precipitate, that indicates bromide. Now, how do I test for sulfate? You should know, add aqueous nitric acid and barium nitrate or aqueous HCl and barium chloride. In both cases, if we have a sulfate, we should get a white precipitate. This next question wants us to draw dot and cross diagram for propene. So, what do we do? First of all, we look at the hydrogens. You should know that for each hydrogen has one electron, so it needs one more because this is the first energy level. So for each hydrogen with a carbon, I'm going to put one electron from the hydrogen, one electron from the carbon. And then I complete the carbon. So that carbon on the left already got 3 electrons from the 3 hydrogens, so it needs only one more from the neighboring carbon. But the carbon in the middle, it got 1 from the carbon on the left, 1 from the hydrogen on top, so it still needs 2 more. So it's going to get it from the neighboring carbon on the right. So this is the overall dot and cross diagram for propene. Describe the forces of attraction that hold the atoms together in a molecule of propene. You should realize that propene is covalent. The bonds inside are covalent. So this question is basically asking what is meant by covalent. So when the question says, describe the forces of attraction that hold the atoms together in a covalent molecule, that means explain what is meant by covalent. This is strong electrostatic attraction forces between what? Between the shared, the bonding pair of electrons, the electrons in the middle that are being shared, and the positive nuclei of the atoms that are sharing these electrons. This is what we refer to as a covalent bond. The alkane pentadecane has this formula. Describe how propene can be produced from this long chain alkane. If we have a long chain alkane, so this is something that has 15 carbons, how do I get shorter chains? You should know that breakdown of long chain hydrocarbons into shorter chain, this is what we call cracking. Cracking is the breakdown of long chain hydrocarbons into shorter chain. And you should know that cracking is done using aluminum oxide catalyst and 600 to 700 degrees Celsius. And you should also know that cracking can either give alkene plus alkane or alkene plus hydrogen. And this is actually how we make hydrogen. Remember, there is no hydrogen in the air. So if we need hydrogen for a reaction, it is obtained from breakdown or cracking of hydrocarbons. Propene is used to make polypropene. Complete the equation for the formation of polypropene. How do we write the polymer, or how do we draw the polymer from the monomer? So we have propene that has a double bond. When we do polymers, the double bond becomes single, and we put a new bond on the right, a new bond on the left to join them to other molecules like itself on both sides, and then we complete each carbon with whatever was attached to it in the beginning. Of course, this is what we call a repeat unit, so this has to be repeated n times, and that is what we call polypropene. Explain why the disposal of polypropene is a problem. So when we throw it in dump sites or what we call landfill sites, why is that a problem? You should know that polymers are non-biodegradable, so they accumulate in dump sites. They're not broken down by bacteria, so they just sit there for years and years. Propene can be converted into compound X, and we're given the percentages of carbon, hydrogen, and oxygen in X. We are told that compound X has an MR of 60. Determine the molecular formula of X. Of course, to get the molecular formula, we first need to get empirical formula. So how do we get the empirical formula of X? We have the percentages of each element. First, divide by the mass number of each of them. So carbon by 12, hydrogen by 1, oxygen by 16. And the numbers that come out, we need to simplify them, so we divide by the smallest. These are the numbers that come out, and that means the empirical formula is C3H8O. Now, we were told that the molecular mass should be 60. Well, let's take a look at the MR of this. When we calculate the MR of this empirical formula, which is supposed to be the simplest ratios of the molecule, it does come out to 60. So this actually is the molecular formula of my compound. So the molecular formula is the same as the empirical formula in this case. Propene and compound X both have simple molecular structures. Explain why compound X has higher boiling point than propene. Of course, if we are comparing two different compounds, both of them are simple. So both of them should have weak attraction forces between molecules. But if we say that one of them has higher boiling point than the other, well, that means that that one has stronger attraction forces between molecules than the other one. And that needs larger amount of energy than the other one. So if we say X has higher boiling point, that means this is because X actually is a larger molecule. It has more electrons, so stronger attraction forces between molecules that need larger amount of energy to be broken compared to the propene. Question 11 says the student uses this method to investigate the temperature change when solid sodium hydrogen carbonate is added to ethanoic acid. So they put 100 centimeter cubed of ethanoic acid into a polystyrene cup, record the temperature, add 1 gram sodium hydrogen carbonate and stir, record the new temperature, and keep adding 1 gram portion, stirring, recording the temperature after each portion, and they got this table. Now, what are we required to do? Plot the student's result, draw a circle around the anomalous result, and draw a curve of best fit. So if we plot the points, this is what we have. Now, which of these is an anomalous result? Remember, the word anomalous means it's away from the curve. Something is wrong from that with that reading. So obviously the one at 3 grams of sodium hydrogen carbonate, that's the one that is anomalous. So I ignore it when I'm drawing the curve of best fit. We do not go out of the curve and then back again. If it is away from the curve, it is anomalous. It is not included in the curve. Explain why using a polystyrene cup makes the results more accurate. Of course, you should know that when we do any experiment that involves measurement of temperature, we should do it in a polystyrene cup, and that is because polystyrene is an insulator. Insulator means it does not allow transfer of heat to the surroundings or from the surroundings. In this experiment, the temperature was going down. That means this was an endothermic reaction, so that the reaction was taking heat from the surroundings. So having polystyrene cup makes less transfer of heat from the surroundings. So just a mistake the students might have made to cause this anomalous result. What do you think was wrong? Well, probably the student did not stir the mixture, or they took the reading too early before the temperature went down as much as it should. State how the results show the reaction is complete. How do I know that the reaction was complete? Remember, at the end, the temperature did not change. The last 3 readings are the same, and that means the reaction is complete. State how the results show that the reaction is endothermic. We said, what is happening to the temperature? The temperature decreases. When the temperature decreases, that means the reaction is endothermic and that the reaction takes in heat from the surroundings. Then the question says, use the results to calculate the heat energy change Q in joules. How do we calculate Q? You should know that Q is equal to mc delta T. What is M? M is the mass of the solution. So the question said pour 100 centimeter cubed of ethanoic acid. So that is our M. C is given 4.2, and the delta T is the difference in temperature. I'm going to point out that the fact that you have in that question that it says 1 centimeter cubed of ethanoic acid, mass is 1 gram, this is not the mass you're going to put in M. This is just telling you that the volume is the same as the mass because the density of the solution is taking as 1, as if it is a pure water. So any volume of solution is the same as its mass in grams. So 100 centimeter cubed is the same as 100 grams. Now the delta T is the difference in temperature. We put that into the equation. That comes out to 2310, and what comes out from this equation is in joules. The student repeats the experiment, starting with a different volume of ethanoic acid. The student uses 7 grams of sodium hydrogen carbonate, and the Q is 3200 joules. So we're doing a different experiment, repeating it in a different way, and we're saying we have Q is 3200 joules, and we started with 7 grams of sodium hydrogen carbonate. We want to calculate delta H. Now, how do we calculate delta H? You should know that delta H is Q over N. We are given Q. It says 3200 joules. So we need to get N. N, the number of moles, is mass over molecular mass. So that is the mass of the sodium hydrogen carbonate over the MR. That's our number of moles. So we put that into the equation. Remember, the Q is in joules, and we want the delta H to be in kilojoules, so we divided by 1000. So the Q is 3.2 over the number of moles, and we got a value for delta H in kilojoules per mole. Remember, you must have a sign for delta H. So We look at the equation, the reaction. Did we say the reaction was exothermic or endothermic? Remember we said the reaction, the temperature went down when the temperature decreases. This is an endothermic reaction, and that means the delta H must be a positive value. So we decided it is plus 38.4 because this is an endothermic reaction. And that's the end of this paper. Thank you for listening, and I hope this was clear. Good luck in all your exams.